Hello everyone, welcome to Imaginary Hub. In the first video of recursion, we have studied the basic concept and we have understand what is the actual meaning of recursion and how recursion works, and we have seen some basic problems. Now in this part, we are going to cover some of the most important problems based on recursions, and these questions you may asked in the interviews, and when you sit in actual interviews or actual competitive coding, you will definitely find these sort of questions. So in this video we have talked some of the top level questions of recursions, which are the problems which are based on recursions, and I want you to watch this entire video completely and you will learn something and you will get a a point of view, or you will get a new mindset towards competitive coding. So with that being said, let us start our next part of recursion. Now let us talk about a very interesting question, and this is like very classical question, that is finding or printing nth Fibonacci number. So what are Fibonacci numbers? So the Fibonacci numbers looks like this. So the sum of two previous numbers, and the number starts with 0 1, and the third number is 0 plus 1, that is 1, and the fourth number is 1 plus 1 2, fifth number 2 plus 1 3, sixth number 5 8 9 10 11 12 13, and so on like this. So the third number or whatever the number is, that number is equal to sum of previous two numbers, and this number is sum of two numbers, and this number is sum of these two numbers, and 5 is equal to sum of these two numbers. So this is how Fibonacci series takes place, and Fibonacci is like a very important series when it comes to sciences, computer science, and like in biology, physics, math, all those things. You can see like in nature, if a person is considered to be handsome, then because then that person has a like a great golden ratio, or the value of his face, or according to the calculation, the face structure or the values of his face is equivalent to golden ratio, and golden ratio is nothing but equivalent to, you can say that, Fibonacci series. And you can see that in flowers, flowers are formed like flowers. You can see that flowers have petals, and whenever you observe that flower petals are in the form of Fibonacci series. And in our DNA is also like some kind of related to, I don't know what exactly, but related to Fibonacci series. So Fibonacci has a lot of like significance in sciences, and it is an important question. So here the question tells that we need to calculate the sum of nth number, or sorry, we need to find the nth number of Fibonacci series. Let us start our like indexes from 0. So here 0 1 2 3 4 5. So user, suppose like let us consider that user asked me the fifth term or like sixth term of my Fibonacci series, then I will print 8 to my user, because at the sixth term the value which is present is 8. So I will print 8 to my user. So this is the basic logic of my question, the basic like asking of my question. Now how I am going to do this question, or what are the things that I will require to perform this question. So to do this question, you need to understand the concept of Fibonacci. So in simple words, Fibonacci is a series in which the upcoming numbers is equal to the sum of previous two numbers. Here you can write, suppose let us consider that 0 1 2 3. So third term is equal to second term plus my first term, that is nothing but Fibonacci of third term is equals to Fibonacci of second term plus Fibonacci of first term. So this is the basic fundamental formula, or whatever you can say, right? Basic logic of this question. So this is the like formula for finding the nth number. So in other words, can I write that my Fibonacci of nth number is equals to Fibonacci, what I told you, that Fibonacci of nth number is equals to the sum of previous two numbers, previous consecutive sum of those numbers. So can I write that Fibonacci of n is equals to Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? Okay, this is the formula for finding my Fibonacci of nth number. So can I write, imagine my recursive function like, let us consider example that Fibonacci of 5 is equals to Fibonacci of fifth term is equals to, that is nothing but fifth term is 5, is equals to Fibonacci of 4 plus Fibonacci of 3 that is nothing but n minus 2. Okay, okay. So can you observe one thing, that the initial numbers of Fibonacci series is 0, 1. These are my initially starting numbers, and from those numbers I will get whatever the numbers I got up to nth number. I can tell, I can like reduce those forms into these two numbers. Yeah, because these numbers are the starting point of my Fibonacci number. So can I write that upcoming numbers is 0, 1, 1, after it next number is 2, after 3, 5, 8, and so on, and these two are my base numbers, or in other words base case. So I will continue calling my recursive functions until I will get my base cases. And the base cases are, if my n minus 1 or any of the call stack or any of the function calling, if my value will become 0 or 1, at that particular case I will return that particular value. I will return either 1 or either 0. I hope you have understood. Now let us do a dry run such that you will understand it even more better. So let us consider that I am calling my Fibonacci of 5. I need to calculate the Fibonacci of fifth term. So what I need to do, or what are the things I needed to calculate the fifth term of my Fibonacci number? So to calculate the fifth term of my Fibonacci number, can I say that I need to calculate my fourth term after third term? If I know the fourth term and third term, then I can simply calculate my Fibonacci of fifth term. So can I write that my Fibonacci of fifth term is equal to Fibonacci of fourth term plus Fibonacci of third term. Okay, what is Fibonacci of fourth term? Fibonacci of fourth term is equals to Fibonacci of third term plus Fibonacci of second term. What is Fibonacci of third term? Fibonacci of third term is Fibonacci of second term plus Fibonacci of first term. Right? What is Fibonacci of second term? Fibonacci of second term is Fibonacci of first term plus Fibonacci of 0. Okay, okay. Here can I write that Fibonacci of second term is equal to Fibonacci of first term plus Fibonacci of 0, and Fibonacci of third term is Fibonacci of second term plus Fibonacci of n minus 2, that is Fibonacci of first term, and Fibonacci of 2 is Fibonacci of 1, and Fibonacci of n minus 2, that is Fibonacci of 0. And you can see that if my n value will become 1 or n value will become 0, right? If any of this condition is true, or if I get any of this condition, then say I will simply return n value. I will simply return n value, right? You can see that if you can see that here n value is 1, so I will return 1. After here n value is 0, so I will return 0. So 1 plus 0, so here finally I will return 1. After that this value Fibonacci of 2 is 1. After Fibonacci 1 is also 1, so 1 plus 1, from this I will return 2. So Fibonacci of 3 or Fibonacci of third term is 2, and Fibonacci of second term is first term plus we already know that Fibonacci of second term is 1, right? So 2 plus 1, so from this I will return 3. And here Fibonacci of 3 is, we already know that Fibonacci of 2 is 1, so 1 plus Fibonacci of 1, so these thing will give me 2. So finally 3 plus 2, so I will get Fibonacci of fifth term as 5. You can see that my fifth term is 5. So this is how I am going to calculate the Fibonacci of nth number. So let me write the pseudocode such that you will understand it even more better. Here now I am going to write my pseudocode. So I am going to return the nth term present at my Fibonacci series, right? So I am going to write public static int type function fib. Here I am passing int n. So first of all, my base case here is if my n become 0 or n will become 1, then return n. Simply return n. After that, what I need to do, I need to calculate Fibonacci of n minus 1, Fibonacci of n minus 2, and add those two. That thing will become Fibonacci of n. So can I write that my int Fibonacci of fib n is equal to fib of n minus 1 plus fib of n minus 2, right? After that, finally simply return fib of n. So this is the pseudo code of my Fibonacci of nth term. I hope you have understood what is Fibonacci numbers, what is the logic to find Fibonacci numbers, and the pseudo code. Now let us code this thing. So I am going to create Fibonacci number. After that, first of all, I am going to create public static int type function int Fibonacci of n. After that, I am passing here n. And finally, first of all, let me write my base case. Base case if my n value n is equals to 1 or n is equals to 0. If any of this condition is true, then return n. That's all. After it here, my work. What work I am performing after my inner calls. So the work I am performing is, first of all, I am going to calculate int fib n value. Fib of n is equals to fib of n minus 1 plus fib of n minus 2. After it, return fib of n. That's all. Here I am passing n is equals to 6th term. We already know that the 6th term is 5. Now I am calling my fib number and printing, right? Fib. Here I need to give static. So we already know that the 6th term is 8, right? Fib n I am passing. Now let me save this thing. Here I need to give statement terminator. Now save and run. So you can see that I got my output as 8. So we already know that the 6th term which is present at my Fibonacci number is 8. So this is how we are going to calculate the Fibonacci of nth number. Now let us do a stack analysis for this thing. So these are my Fibonacci numbers: 0, 1, 1, 2, 3, 5, 8, 13 and so on. And this is my 0th term, first term, second term, third term, fourth term, fifth term, sixth term, and in the previous code we have find out the 6th term, that is 8 and so on. Now let me write the code, or let me print the pseudo code here. This is the code, right? This is the code. Here I am passing n value, and this is my base case. If any of this function calling will become n or 0, then I will return like n. After it, here I will calculate Fibonacci of n. After it, n minus 2, and I will print all. I will return the Fibonacci of nth digit or nth term present at that value, right? Okay, this is how the code works. Now let us do a dry run or a little bit stack analysis. I want to tell you one thing, that Fibonacci series calls takes place in a form of a tree, kind of a tree like structure. Like let us see that here I am passing here let us consider that n is equal to 8. So I need to find out the value, or here I am passing, let us consider that n is equal to 6. So I need to find out the 6th term value present at my index. So I already know that the value which is present is 8. So I need to print 8 to my user as my 6th term. Now here I am passing 6, right? So some stack calls takes place in the form of a tree, right? A tree like structure. So 6 will call 5, that is nothing but Fibonacci of n minus 1. After it, Fibonacci of n minus 2, that is like 4. After it, 5 will call Fibonacci of n minus 1, that is 4, and Fibonacci of 5 minus 2, that is 3, and 4 will call Fibonacci of n minus 1, that is 3, and Fibonacci of n minus 2, that is 2, and here 3 will call Fibonacci of n minus 1, that is 2, and Fibonacci of n minus 1, that is 1, and 2 will call n minus 1, that is 1, and n minus 2, 0. After that, 2 will call 1 and 2 will call 0, and 3 will call 2. After it, 3 will call 1 and 2 will call 1 and 0. After it, 4 will call n minus 1, that is 3. After it, here n minus 2, 0, and 3 will call 3 minus 1, that is 2. After it, 3 minus 2, that is n minus 2, right? So this thing will call 1. After it, here we will call 1 and n minus 2, 0. After it, here we will call 1 and 0. So this is how calls will take place, and the diagram looks like kind of complex, but it is simple in other words. So here what is the base case? So this is my base case, right? If n will become 1 or n will become 0, then simply return the value of n. So here n is equals to 1, so I will return 1. Here n is equals to 0, so I will return 0, and I will add these two values, that is 1 plus 0. So here from this I will return 1, and this thing will return 1. So I will add these two values, that is 1 plus 1. So this thing will give me 2, so I will return 2 here. After that I need to calculate this also, that is 1 and 0. So this thing will return me 1. So 2 plus 1 is equals to 4. So this thing will return me 4, and I need to calculate 3. We already know that Fibonacci of third term is 2. So this thing will return me 2. So 5 plus 2. So this thing will return me 6, and Fibonacci of 4. Wait a minute. Yeah, Fibonacci of 4. Here I need to call yeah, okay, good, right? Fibonacci of 5. Okay, sorry, 3 will return me 1. Sorry, 3 will return me, right? 5 minus 2, right? So this thing will return me 1, and I will return here 5 value. So I will return 5 here. After it, you can see that the fourth term. So fourth term will return me 3. So finally the sum will become 5 plus 3, and I will return 8 to my user. So the sixth term is 8. So yeah, the sixth term will become 8, and I will print that value to my user. So this is how a huge tree-like structure or a function calling takes place for my Fibonacci numbers. And you can see that here I am calling like 4 one time, second time, and like if I am calling 4 two times, and I am calling 5 one time, and I am calling 6 one time, and I am calling 3 1 2 three times. After 2, how many times? 1 2 3 4 5 4 5 2 5 times. After 1, like 1 2 3 4 5 6 7 8 times, and 0 1 2 3 4 5 0 5 times. So I am calling the same value again and again. Here in one function call I got to know the value, and in spite of that value, in spite of knowing a particular Fibonacci of nth term, I am calling it again. This is because this is not efficient like code. Let me show you. So here in the place of n, let me pass like 70, at least 70th term. Now let me save this and run. You can see that my output is not printing. It is like taking too much time to print, because for 70 it will form a like huge calls takes place, huge number of calls will take place. What I told you, that the three conditions are: if the function call is too big, after that the second is if we are passing huge parameter, or third one is if we didn't give the base case. If any one of this condition is true, then we will get a stack overflow. Here we are calling like a tree-like structure, like we are calling too many nodes or too many like numbers of nth terms. When I pass 70, 70 will call 69 68, and 69 will call 68 67, and these calls like continuously call each other and try to find out the value, and this process will become so complex that it is taking like too much time for my computer to calculate. Suppose let us take here, I am giving like 25. So it can calculate easily. So you can see that I got my output as 75,000. Let us take let me print here. I will copy the same value here and print, and here I am passing n minus 1, n plus 1. I am calling for 26, 27 and 28. Now let me save and run. So you can see that for 25 my value is 75,000. For 26 the value like almost got doubled, like 1,21,000. After that for 27 my value like got like increased to like almost like kind of double, that is 1,99,000, 96,000. After that for 28 my value like got again big, that is 3,17,000. So you can see that my value is doubling each and every call. Each, and if I increase the value of n, then my Fibonacci number will get increased by 2 times. So if I call 70, then that is a huge value, huge term. That's why it is taking too much time. So you can see when we study dynamic programming chapter, then we'll do the same Fibonacci series in a very efficient code using some methods and tricks. So this is the basic function calling using recursion, right, to calculate the Fibonacci of nth number. I hope you have understood the logic and the function call of Fibonacci series. Now in this question we need to calculate or we need to find out whether the given array is sorted or not using recursion. Now let us take example for a sorted array, that is 1, 2, 3, 4, 5. Now the logic or the thing which we are going to apply is, first of all we are going to compare these two things. So before we dive into recursion, let us consider our iteration approach. So in iteration approach, what we used to do, we will compare, like we'll run a loop, our outer loop and our inner loop, and we'll compare if my ARR of I is greater than is less than ARR of I plus 1. If this condition is true, then it is a sorted array. If not, then it is not a sorted array. So iterative approach is like simple for this thing. For calculating whether the array is sorted or not, iterative approach will give me like in seconds, whereas recursive approach is like kind of hard, I guess, but it is also a good way, it is also a good efficient code to write. So here the recursive approach is, first of all we will compare the first digit with the second digit. If this is less than, uh, uh, if 1 is less than 2, then we'll put a recursive call for this array. For this array we'll do recursive call. After that we'll compare these two things. If this thing is true, then we'll apply the recursive call for this thing, and after it we'll apply if these two things are less than, or if these two things can satisfy our condition, then we'll apply this sorted these for recursive call, the rest of my array for recursive call, and after it for this array, yeah, a single element, so the given array is sorted. So this is how we will find out the whether the given array is sorted or not. Now let me write the pseudocode such that you will understand it even more better if I write the pseudocode. So our pseudocode will start public static boolean type function. I am going to return either true or false. If the array is sorted, then I will return true. If not, then I will return false. So public static boolean is sorted is my function name. After that I am passing here int arr, after its initial index I. Here I'm the base case is yes, if I got my if I completed all my iteration for the complete array, then what it means, if I like get to like apply all my recursive calls for the whole array, it means that the given array is sorted. Okay, so if my array, if arr dot length is equals to I, if this condition is if I got this condition, then I will return true. After that I'm checking if arr of I is greater than arr of I plus 1. If this condition is true, then it means that the given condition or the given array is not sorted. That means that it looks like this. If the array, our array looks like this. If we got condition like this, then we will return false. Return false. After that we will return, finally we will call the function for our same array, that is sorted. We will call for the rest of my array, that is nothing but arr of I, arr. After that we will increase the I value, that's all. This is the code, this is the pseudo code. So what I am doing here, let us consider that 1, 2, 3, 4, 5. First of all I am checking these two. If this condition is true, if that is 1 is less than 2, then I will call for my same function, my inner function calling for this array, right? After that I am comparing these two values. If this is also, that is 2 is less than 3, if this is also true, then I will call for this array and I will check these two, right? If this is also true, that is 2 is less than 4, then I will call this array, and if this is also true, then what I am doing, I have called my function for all the array, for all the array elements. So you can see that I have called all the array elements. So starting from this, I have called all the elements. So if I called all the elements and our inner function call is also taking place, then what I will do, I will return true. If any one of this, like I got my base case, like that is 2 is not less than 1, then immediately I will return false. right? This is how our function calling takes place. Now let us code this thing. Now we are calling our function is sorted. So I'm going to create public static boolean type function. Boolean is sorted. In this I'm passing int arr after index int I. Our base case. Now we are going to write our base case. So what is our base case? That if arr or I will become I is equals to arr dot length. If this condition I got, then I will return true. After that, if my like arr of I is greater than arr of I plus 1, then I will return false. After that, what I am going to do, I am going to call my function for the rest of my array after comparison. Right here, I am going to call my function after rest of the array. That's all. Now here let me call my let me create my function int arr is equals to, let me give a sorted array 1 2 3 4 5. After that, I am calling my function, that is whatever the function value that will get returned, I am printing it, and now I am calling int arr I is equal to 0. Now let me save this thing and run. So you can see that we got our output as true because we have passed a sorted array. Suppose let us consider that I am passing an unsorted array. You can see that this is the unsorted array. Now let me save this thing and run. So you can see that I got my output as false because the array which is passed is unsorted. Now this is the code for finding whether the array is sorted or not using recursion approach. Now this is how the code works. I hope I have understood the logic and the working of my like is sorted function in a recursive approach. So for iterative approach, we will run a loop and we will check for each element. If my arr of I is less than arr of I plus 1, then return true or return false. Like that we use our iterative approach. But here we are checking for arr of I, if any of this previous element becomes like greater than my like upcoming current element, then what we'll do, we'll return immediately false. After it, we'll call a function for the rest of my array. So if I called like for the whole array we have called the function calling, then it means that the given array is sorted, right? If it is sorted, then what I'm going to do, I'm going to return true to my user. So this is how the function calling and all those things works. Now in this question we need to find the first occurrence of a particular element in the given array. Now let us take example to understand like how what is the meaning of this question. Now let us take an array like 8 3 6 9 5 10 2 5 3. So let us consider that this is my array. Right, 0 1 2 3 4 5 6 7 8. So these are my elements present in my array, right? Suppose if the user has given me a key value, that is key is equals to 5, so I will check at each point, I will check at each point I will check whether the given element is our key or not. If it is key, then I will return my index. So here you can see that this is my first occurrence. So you can see that in our whole array 5 has arrived, or 5 we got 5 at 2 indexes, that is I is equals to 4, I is equals to 4, at I is equals to 7 also we got our element, that is 5. So 5 5. So here we returned our index I value, right? Our index I value, that is what is the first occurrence? First occurrence is I is equals to 4, so we will return 4 to my user. So this is how the basic like asking of our question, asking of this question. Now here we need to like return the first occurrence or the first index of my like given element. Here first occurrence of 5 is 4 and the last occurrence is 7. So what is the logic here? So the main logic here is we'll like iterate or will like approach each element for the given array. If that particular element is equals to our key, then we will return its index. If not, If not, then we'll call our recursive function to my rest of my array. Like let me like write here 5 6 9 8 7 10 2 5 3. This is my array, right? Yeah, this is my array. So I will check first of all for first index. I will check whether my key here, key is equals to 5, is equals to element present. No, it is not. Then I will call my recursive function to the rest of my array, and I will check for this element. So my key is 5 and the element is present 3, so I will call rest of my array. So the key is 5 and the element is 6, so again I will call the for rest of my array except that particular element, right? Okay, now I will check for 9. Again, the element is not equals to our key, so I will call rest of my array. You can see that key is equals to our element, so I will immediately return its index, that is 4, and I will come out of the function. So this is how function calling takes place for my given question. Now let me write the pseudocode for this thing. So first of all, I am going to write a public static integer type function, because I am going to return the index of that particular index, particular element, right? So int, after it I am going to write first occurrence. In this I am passing int arr, after it int I, that is my index value, after it int key value. That's also if I is equals to arr dot length minus 1. So if I called my all my function for the rest of my array, but I didn't get the value of my particular key, then what I am going to do, I will return minus 1. It means that the element which is not present in my given array. So return minus 1. After that, if our arr of I is equals to key, then return I value. That's all. After that, finally return first array, first occurrence for my rest of the array, right? So I'm passing arr, after that key, same key, after that I plus 1. That's all. So this is the pseudocode for my function. Now let me code this thing. So here I'm going to call public static integer type function int, after that here is first occurrence, in this I am passing our array int arr, after it int key, after it int index. First of all, my base case is if arr our I is equals to arr dot length, then return minus 1. If arr of I is equals to our key, then return I value. After that, I need to call my function and my work here, right? Work. So I am going to return the rest of my array function calling, that is first occurrence. Here I am passing the same array, same key, but the index is going to change. That's all. Now here I am passing. Let me write my function call. First occurrence. Here I am passing my array, same array, and let me pass my key as 3. After it, my index initially is 0. That's all. Now let me save this thing. You can see that 1 2 3, it is 0 1 2. So for third element the index is 2. So if I run this code, then I will get my index as 2. Now let me save this. So you can see that I got my output as 2. That is my, you can see that in the array, given array, the index of third element is, that is 0 1 2, right? The index is 2. So I will print it, I have printed the output as 2. So this is how the code for first occurrence is, and this is how it works. Now let me save this thing, and I hope you have understood the logic and the working of first occurrence question. Now in this question we need to find or print the last occurrence of the given element. So this is kind of a reverse question for our previous question, right? This is kind of a like reverse order question. In the previous question we found like the first occurrence of a particular element in my array. Here we are going to like find out the last occurrence of the given array, right? Okay, now let us take an example that the given array is 8 3 6 9 5 10 2 5 3. So this is my given array and we need to find the key is here key is equals to 5. So the last occurrence is 0 1 2 3 4 5 0 1 2 3 4 5 6 7 8. So the last occurrence is you can see that the last occurrence is not 4 but 7. So will return 7 to my user as my last index. So how we gonna do this? Here we just bring a small change. Whatever the base case, the pseudocode will remain same, but the only change here is in the previous example we used to check like suppose like this, let us consider this is my current element. So in the previous question we used to check whether the current element which is present at my index is equals to my key or not. So we used to check the current element itself. Now here we are not going to check with the current element. First of all we will check with the rest of the array, after that with my rest of my with the current element. So first of all let us consider that here the current element is 4 8. Let us consider that the current element is 8 at my 0th index. So I will first of all I will not check whether the key is equals to my current element or not. First of all I will check with the rest of the array. If it is present in my rest of the array, then I will print that particular index. If not, then I will check with the current element and I will print that particular index if it is equals to key. So this is the like minor difference in like first occurrence in last occurrence question. This is a minute difference, that's all. Now the pseudocode will remain same, that is we will write public static integer type function after last occurrence, and this I am going to pass my array the same key after my index. Here the base case will remain same, that is if arr dot length is equals to I, then return -1, that is my element is not present in the array, given that is key is not present in my array. After that I am going to create is found function. So is found function will check for my rest of the array. So last occurrence, here I am going to pass IRR key I plus 1. Right, after that if is found is equals to -1, that is it is present somewhat in the array at the last index or at the like present AR of I is equals to key. If it is present in any one of the indexes, then what I am going to do, I am going to return I value. That's all. And finally whatever the value I found, I am going to return in the is found function. That's all. It means that here if statement describes that in the last occurrence if the element is not present, or you can see that and if my in the given in the given array the current element is the like you can see that. Let us take example to understand the if statement. First of all I am checking if my given this is my current element. So the what I told you that we will not check for the current element whether the current element is present or whether the current element is equals to key or not. What we do will like first of all check for my rest of the array, right? If it is present the element is present in my rest of the array, then we will print that value, that then we will print is found value, right? Okay, if it is not present in my rest of the array, then what we'll do, we'll print the current element. So if in the if statement we are like doing the same thing, we are printing the current element. If it is not present in my rest of the array, then we will print the current element. So if statement will print current element and is found statement will print the element in the rest of the array. So this is the minor difference, and I hope you have understood the logic. Now let us code this thing. So last occurrence. So here first of all we are creating public static int type function last occurrence. In this I am passing array int arr, after that int key, after that int I value. Here if my I is equals to ARR dot length, then return -1. After that, int is found is equals to last occurrence. Same, the array will remain same, only changes the index. After that, I'm checking if is found is equals to -1, and ARR of I is equals to key, then return I. After that, return is found. That's all. Now let me save this thing, and here in the place of first occurrence, I'm calling my last occurrence. And here in the last index, I am like here in the place of 0, I am passing 3. So the last occurrence of 3 is 0, 1, 2, 3, 4. So if I run this code, then I should get the output as 4, because the last index of my last occurrence element is 4. So let me save this thing and run. So you can see that we got our output as 4. So this is how the last occurrence of the given element works. Now in this question we are going to calculate the power of the given number. Let us take the power of the given number as x to the power of n. Now in this question we are going to calculate the power of the given number in an optimized way. In the previous chapter, in bit manipulation chapter, we studied like fast exponent question, right? And in that particular question, we using bit manipulation techniques, we found out the power of the nth number. Now in this chapter we are going to find out the power of the given number using recursive approach. So generally, what is general method to calculate power of n? So we'll run a loop, we'll run a for loop for int I is equals to 0 up to n times, and in this we'll calculate n into n into n into n up to like m times to calculate n to the power of m. So we'll run a loop, and this is not like that much optimized or the efficient code. So in this we are going to learn the optimized code for this thing. So can I write that my x to the power of n, x to the power of n is equals to x to the power of n by 2 into x to the power of n by 2? Yeah, I can write like that. In math we used to study like in exponents and the type of chapter like integration, we used to study like these kind of formulas. So can I write my x to the power of n is equals to x to the power of n by 2 into x to the power of n by 2? So yeah, this is absolutely right. Okay, and can I write that x to the power of n by 2 is equals to x to the power of n by 4 into x to the power of n by 4, and x to the power of n by like 8 is n by 4 is equals to x to the power of n by 8 into x to the power of n by 8, and x to the power of n by 8 is equals to x to the power of n by 16 into x to the power of n by like 16. And these calling or like these function calling will continue until my n becomes 0, and if my n becomes 0, then we already know that x to the power of 0 is equals to 1. So this will become my base case. So can I write that my x to the power of n is equals to x to the power of n by 2 into x to the power of n by 2, and this thing is equals to x to the power of n by 2 is equals to n by 4 into n x to the power of n by 4, and this process will continue until x to the power of 0 will get. So if I get x to the power of 0, then this is my base case. This is my base case, and from this I will return 1, and the returning will work, and finally I will get my x to the power of n value. So this is the main logic of my code. So let me write the pseudocode such that you will understand it even more better. So first of all, I am going to write my pseudocode, that is public static int optimized power. In this I am passing x value and n value int n, right? So what is my base case? That is if my n is equals to 0, then return 1. Okay, this is my base. After that I need to calculate power of the half power, right? So to calculate half power, I am creating int half power is equals to, I am calling my recursive functions, that is power of n a comma n by 2 into optimized power a comma n by 2, right? After that, this is for my even number. Suppose let us take like x to the power of 5. For that I need to calculate like x by 2 plus 1. So can I write that my, because n is integer, so n by 2 will also become an integer. It don't store like 2.5 or these kind of values. So can I write that x to the power of 5 is equals to x to the power of 1 into x to the power of 2 x to the power of 2. So can I write that x to the power of 1 into x to the power of n by 2 x to the power of n by 2, that is nothing but a here I am passing a, right? Okay. After that, a to the power of n by 2, a to the power of n by 2. So for odd numbers, can I write like this? Yeah. So for odd numbers, if my n modulo 2 is not equals to 0, then in this my half power will become half power is equals to a into half power. So this is my half power, I am multiplying with half power, that's all. After that I will return my half power, that's all, half power square, that's all. This is how I will calculate the power of the given number. Now let us code this thing. Power of the given number. First of all, I am going to create my function public static integer type function, because I am going to return the power of the given number. Let POW, in this I am calling I am passing int n, after that int a, after that I am passing int n. The base case is if n is equals to 0, then return 1. After that I need to calculate my half power square. Half power square is equals to power of a comma n by 2 into power of a comma n by 2, right? This is for my even case. If it is odd, that is n modulo 2 is not equals to 0, then my half power will change into half power square is equals to POW of a into n into half power into half power, that's all. After that I will return my half power square, that's all. Now let me save here, and in the place of array I am passing int a is equals to 2. After that int n is equals to 2. So 2 square is equals to 4, right? So I will I will get my output as 4. So I am calling my function and I am passing a value and n value. Now save this and run. Here I need to give a, right, not function calling, right? A into half power square. Now let me save this thing and run. So you can see that we got our output as 4. So a is equals to 2 and n is equals to 2, and 2 to the power of 2 will give me 4. Suppose let us consider that here I am passing like 20, and let me save and run. So this thing will give me 102 to the power of 20 is 104 8576. So this is how the working of calculating the power of the given number works using recursive approach. I hope you have understood the concept and the working of the power of calculating the power of the given number. Now we are going to do an interesting question and a very important question, that is styling problem. Hello everyone, now we are going to solve a problem which is very important. You can see the same problem in Lead Code, Hacker and CodeChef, like coding platforms, and these sort of questions are asked when it comes to product companies like Amazon and Google. These sort of questions are asked in like some scenarios they may ask you like different question, but the concept of these questions are in interviews, so the form of the question may change, but the concept remains the same. In this question, before we dive into the technical aspects of this question, in our houses we can see that on our floor we place some tiles such that it will look beautiful and it will give some attraction. Similarly, in this question, given a 2 cross n board, or you can say floor floor and tiles of 2 cross 1. So a floor looks like this. A floor, given floor looks like this. That is the length or the first dimension of our board is 2. After that, the length is n. So here this is the floor that represents the dimension of our ground or whatever you can say floor. After we have user has given us the tile dimensions. That is, this is the tile dimensions. The dimension of tiles is 2 cross 1. This is 2 cross 1. So this is our tile. So somewhat tiles look like this, and a tile can be placed on top of floor either in vertically or horizontally, and we need to find out the number of ways that tile can be placed on the board, and the dimension of the tiles is 2 cross 1. So here I can place our tile like this, and I can place my tile horizontally, I can place my tile vertically, I can place my tile whatever the horizontally and vertically combination. So in this question I need to tell my user that what are the number of ways that the tiles can be placed on top of our board, on top of a board or floor, whatever you can say. So this is the basic asking of my question. Now let us take an example to understand the concept of the question even more better. That is, the dimension of our board or the floor is 2 cross n, right? And here n will be given by our user. Now let us consider that n is equals to 3. N is equals to 3, so that our floor dimensions will become like this. Here this is our floor, and the first dimension is 2 and the second dimension is 3, right? And let me change the pen for my representing tiles. So let us consider that this is our tile, right? The size or the dimension of the tile is 2 cross 1. 2 cross 1. So I can put, for n is equal to 3, I can put the first way will be, I can put all my tiles vertically. So here let us consider that this is my first tile, this is my second tile, and this is my third tile. So by putting all 3 tiles vertically, I can able to cover the area of my floor. So first one is placing all vertically, right? Vertically. So the first way will be placing our all tile vertically such that it will cover all the area, that is 2 cross 3 area of my floor. After the second way will be first tile I am placing it vertically. This is my floor and I am placing my first tile vertically such that it will cover one part and 2 parts will get remained remains. After here I can place my tile horizontally such that it will cover, the total length is 2, right? So it will cover half of the length of my floor. After that I can place another tile horizontally. So this is the second way I can put my tiles. After the third way can be, I can first of all place my tiles horizontally. I can place my tiles horizontally, after my final tile vertically, such that it will cover all 2 cross 3 area. So they are, when n is equals to 3, number of ways will become 3. So here we can see that when n is equal to 3, number of ways is equal to 3. So this is how, these are the 3 ways. That is, either I can put my tiles all vertically, or either in the form of or the combination of horizontally and vertically. So these are the number of ways that I can place my tiles, right? These are the 3 ways. So this is the third way. I can place my tile vertically or horizontally. So these are the 3 ways, such that for n is equal to 3 I can place, these are the 3 ways. So I need to print 3 to my user. So let us understand how we can approach these sort of questions. I hope you have understood the concept of the question. Now let us study, or let us observe how we can approach this particular question. So what I told you in the previous lectures, I told you that there are 3 things which we have to keep in mind when we are going to do a recursion problem. Those 3 things are, first of all, base case. So we need to understand what our base case is going to be. What is our base case? After second one, the work which we are going to perform on top of our recursion calling and all those things. What is the work I am going to perform in our recursion or in my function? After, the third thing is inner function calling. Inner function call. So if I get clarity on these 3 things, then I can solve any kind of recursion problem. Now let us first of all understand how we can get base case for this particular question. So in this question, the basic need or the basic asking is, user will give us a 2 cross n floor On top of that we are placing tiles, and the dimension of tiles is 2 cross 1, and we can place either tiles vertically or horizontally or a combination of both, and we need to tell user that what are the number of ways such that we can put those tiles on top of the given floor. Right, this is the basic asking of our question, and we need to give the user that number of ways that can be possible for this how many ways that we can put the tiles on top of our floor such that it will cover all the area provided for our floor. Right, so to approach this question we need three things: what is our base case, what is the work I'm doing, and defining our inner function calling. If we can define or we can get these three things, then I can easily solve this question. So first of all, let us talk about our base case. So base case, so to approach base case or to get base case, let us take some example that when n is equals to 0, it means that our floor is like single line with 2, right, 2 cross 0 dimension. So in this, number of ways will become 1. Number of ways is equals to 1. After that, for n is equals to 1, that is 2 cross 1. These the floor looks like this for 2 cross 1. This is 2 and this is 1. And what is our tile dimension? Tile dimension is also 2 cross 1. So we just need to put our tile vertically on top of our given floor when n is equals to 1. So when I put the tile on the top of this floor, it will cover all the area of my floor. So the number of ways that can be possible, I can't place my tile horizontally because it will go out of the floor. So I can't put my tile horizontally for this case. So for n is equals to 1, number of ways will become number of ways is equals to 1. After it, for n is equals to 2, n is equals to 2, the area will become 2 cross 2. In this, I can place my tile, 2 tiles vertically. This is my first tile and this is my second tile. So I can place my tile, both tile vertically, such that it will cover all the area. And the second case can be, I can place my tile horizontally, such that it will cover, when I place my tile, 2 tiles horizontally, it will cover both overall area of my floor. So the number of, but I can't place 3 tiles or 4 tiles because it will go out of my floor. So it can't be possible. So in this case, when n is equal to 2, number of ways will become 2. After that, for n is equal to 3, we already studied in the previous example that for n is equal to 3, number of ways will become 3. So from these cases, can I extract one thing that if n is equals to 0 or n is equals to 1, this will become my base case. So what I am going to return here, I am going to return 1 to my user. So this thing is my base case. After that, the work I am going to perform. So can you observe the one thing that at every recursion call, what I am performing or what I am trying to do, I am trying to make a choice here, right? What choice? Either I can put my tile vertically, either vertically or horizontally, right? For a particular given, like at a moment of time, I can put either my tile vertically or horizontally, right? So I am trying to make a choice. Right, do I put my tile vertically or do I put my tile horizontally? So I am logically thinking, and from our logic we are trying to place our tile either in vertical format or in horizontal format, right? Okay, so let us consider a 2 cross n board to understand it. So for vertical case, if I put my tile vertically, then what happens? So this is my board, right? So if this is n and this is 2, right? So if I put my board vertically, if I put my tile vertically, then it will cover one length of my total length of my floor, right? So it will cover one portion of my total length. So the total remaining area will be n minus 1, right? Okay, so let us consider a function that will describe the area of the floor, that is f of n is equals to 2 cross n. So if one portion is covered, then our area will become f of n minus 1. For that particular scenario, we need to calculate, or we need to place number of tiles for n minus 1 area. So if I place my tile vertically, then I need to think about these remaining portion I need to think about, right? I don't need to think the area which on top of our tile is placed. I don't need to think about it. I need to think about the rest of the area which is remaining out there, right? So for vertical case, I need to fill. For vertical case, I have put my tile and the remaining area is n minus 1. So I need to fill my tiles, tiles for n minus 1 area. So I need to call the function for vertical placement plus f of n minus 1 calls. So I need to do f of n minus calls, or you can say f of n minus 1 remaining area. So for horizontal scenario, I am placing my tiles like this. So it will cover two part, right? The remaining part will be n minus 2. So for this particular case, I need to fill my tiles for n minus 2 area, right? Either I can, for that particular n minus 2 area, again I have to make choice. Either I can place my tiles vertically, or either I can place my tiles horizontally, right? Okay. So for filling n minus 2 area, the formula will become horizontally. I choose, right? If I choose horizontally, then my total number of calls will become horizontal plus function of n minus 2. That is, function of n minus 2 is equals to horizontal 2 into n minus 2, right? So can I write that my total number of ways, can I write one formula that my total number of ways will be f of n minus 1 plus f of n minus 2, right? This will become my total number of waves. So we already know that this is my base case. After it, at each recursion call, I am going to make a choice. Either I can put my tail vertically, or either I can put my tail horizontally. If I put my tail vertically, then I need to think about the remaining portion of my floor, that is n minus 1 area. I need to, for n minus 1 area, again I need to make choices, and these choices will continue until I reach my base case, right? Okay. After it, if I choose a horizontal case, then I need to put two tiles and it will cover two length path area. After it, I need to think about n minus 2 remaining area for our given floor, and for n minus 2 area, the recursion calls will continue until I hit my base case. So these process will continue, and you can see that in previous question for Fibonacci series, we calculate, right, the tree like structure. For this thing also we got, when we draw the things, or when we demonstrate in diagram format, we can see that a recursion call will take place in the form of a tree, right? Okay. So to calculate the total number of ways that can be possible for placing n number of tiles on the given area of my floor, the total number of ways will be vertical area plus horizontal area. So these thing will give me vertical area, and this thing will give me horizontal area. By adding these two, we can calculate the number of ways that can be possible to place our tiles on top of a floor. So this is the basic understanding. We have defined our work that at every iteration we are going to make choice, either vertical placement or horizontal placement. If vertical placement, then recursion call will go for n minus 1 calls. So if horizontal placement, then our recursion call will proceed with n minus 2 remaining area. So this is my work. After, the inner loop looks like this. So inner function calling looks like this. So I hope you have understood the three fundamental things for every recursion question and for this particular question. Right, now let us code this thing. So here, first of all, I am going to create my function tiling problem. First of all, I need public static int, because I am going to return the number of ways that can be possible, right? So int type function after tile problem. In this I am passing n value. That's all. After here, first of all, let me give my base case. In the base case, if n is equals to 1, or n is equals to 0, if any one of this condition is true, then return 1, right? Okay. After that, my work is first of all I need to calculate the vertical. For vertical, uh, int f of n minus 1, right? So f of n minus 1 is equals to, I am going to call my tile problem for remaining portion, that is n minus 1 calls, right? Okay. For horizontal, uh, that is f of n minus 2 is equals to tile f of n minus 2. After that, I need to calculate my total number of ways. Total number of ways. Right, to calculate total number of ways, into total ways is equals to fn m1 plus fn m2. That's all. And finally return total number of ways to my user. That's all. So the code might seem simple, but it is very important to understand the logic of this question. So at every iteration, at every recursion call, so suppose let us take the given area is 2 cross n, right? Suppose at every recursion call, here we have declared, right, by taking some examples by trial and error method, we found that our base case. Now we need to understand how the work is going on in our recursion or our function or in our function. So to understand what is the work going on, we need to understand the combination of vertical placement and horizontal placement. So let us consider that this is my 2 cross n area. So for 2 cross n area, at every recursion call, I am going to make a choice. Either the given tile I can place it in vertical format or in horizontal format. So if I place my tile vertical format, then I need to calculate the number of ways that can be possible. The vertical format is done. This portion is completed. I need to think about the rest of the portion. So for rest of the portion, I need to calculate the number of ways that can be possible for my rest of the portion. So the area, the length is 1. That is 2 cross n, right? So one portion is completed. Now in the n portion, one portion is completed. The remaining portion is n minus 1 portion. So I am calling for vertically. You can see that on the line 114, I am calling function m1 is equals to tile problem. I am calling n minus 1. For n minus 1 area, I am calculating the number of ways, right? Okay. If vertical format is completed, then we need to think about if I place my tile in horizontal format. Suppose like I am placing my tile like this format, so it will cover two parts of our portion, right? Two units of our given area, right? So the remaining area will be n minus 2. Okay. So for that particular thing, we need to calculate the horizontal portion. So you can see that I am calling a function tile problem for n minus 2 recursions. Right, after that I am adding both horizontally and vertically, because I need total number of ways, right? I don't need like only vertical ways. If the interviewer or the question asks you that we need only vertical ways, then you just return vertical ways. If the question asks you that we need only horizontal ways, then you just return horizontal ways. If he asks that total number of ways, then we need to do the sum of both horizontal and vertical thing, and these sum will give me the total number of ways that can be possible to place given tiles on top of our floor. Right? Okay. So we are calculating the whatever the values that got returned by our functions for vertical and horizontal placement, and we are summing those things. After that, we are returning to our user. So this is how the vertical or tile problem takes place. I hope you have understood the question. I tried my best to like explain you like around for 20 minutes. Now in this main program, I am going to give n value as int n. Int n is equals to 3. After that, I am going to call my function, and first of all I am printing whatever the value returned by my tile program. So tile program I am passing n. We already calculated that when n is equals to 3, the output number of ways should be 3. So let me save this thing and run. So you can see that we got our answer as 3. So if I give like here like 4 as my input, that is 2 cross 4 area, then the answer will be, let us see what the answer will be. You can see that 5. Suppose if I give like around like 10, then let me save this thing and run. So the number of ways that can be possible will be 89 ways. So when for the area that is 2 cross 10 area, the number of ways that can be possible to place our tiles are 89 ways. So I hope you have understood the logic here, that this is not a linear format. This is like an exponential format. As the n value increases, our number of ways increases exponentially. I hope you have understood the question. This is the code for calculating tile problem. Now let us do another interesting problem, that is friends pairing problem. So whenever we are in a party or any kind of thing, some people like remain quiet, they don't talk that much. Those people are kind of introverts and all those things, and some people like very extrovert, they want to talk with everybody, they are making like connections, they are making network and all those things. So in this question also, user will give n number of friends, and each friend can have two choices, that he can remain single, he don't talk with anybody, or remain like single person in the group, or he can make friends, he can pair up with somebody, but he can pair only once. Here is the condition, that the given friend can pair with only one given person. After that, we in this question we need to find the total number of ways in which n number of friends can remain single or can be paired, right? So to understand this question, let us take an example that like in a party, there is a friend, so a person can like remain single and like just drink and eat whatever he can do, like just check his phone and all those things, he don't talk with anybody, he can do this. But he can also like talk with another person, he can also like talk person with that particular person, he can also make like a pair with that person. So these talking or all those things is known as pair, and remaining like all by himself is known as single. So in this question, a person can, given n number of people, a single person can make pair with another person or can remain single, right? So he can have two choices. So here is the condition. In this every friend can only pair once, can only pair once. So let us consider that there are three persons, A, B, C. A, B, C. Suppose if A and B like paired with one another, then he can't pair with C, or he can't pair, B can't be paired with C, or A can't be paired with C, because these two guys A and B are a pair, so they can't pair with another body because they already got paired, right? So this is the basic requirement or the basic condition of this question. In this question, given n number of friends, we need to find out that the number of ways a person or a given number of n friends can remain single or can be paired. We need to written n number of ways, right? Number of ways that can be possible, like either he can be single or he can be like paired with anybody, and in most of the cases we guys are single. Okay, so yeah, now let us understand the three things. The three things are, first of all, we need to understand our base case. After what work I am going to perform, this is like very similar to our tiling problem. After, the third one is understanding our inner function call. Right, these three things we have to understand. To understand base case, let us take a scenario that let me first of all clear this thing. So to understand this problem, let us take an example that there are three persons. A, B, C. So A can remain single and B, C can form a pair. After A and B can form a pair and C will remain single, or A and C can form a pair and B will become single. So these are the three ways, and the fourth way can be possible, that three of them will remain single. Three of them are introverted guys, such that they don't talk with one another. Right? So these are the three ways for given three friends. These are the four ways that can be possible for three friends. So to understand what is base case, or to find out the base case, let us take example that for n is equals to 1. For n is equals to 1, there can be like only one friend. So the number of ways that can be possible, he is only one, so he will remain single. So number of ways will be 1, right? After, for n is equals to 2, the two persons can remain single, right? They don't want to talk with one another, so instead they will remain separated and they will do their stuff or whatever the things they want, like they can remain single. After, the other way can be the two persons can form a pair, so the number of ways will be 2. After, when n is equals to 3, we already seen that the three friends, that is A, B and C. like three friends, so a comma b comma c, both of them, three of them want to be single. This is one way. Or a comma b form a pair and c will remain single, or a comma c will form a pair and b will remain single, or b comma c will form a pair and a will remain single. So the number of ways that can be possible is like 4 here. So the base case here is when n is equals to 1, number of ways is equals to 1. So if n is equals to 1, or here when n is equals to 2, number of ways is equals to 2. So when n is equals to 1 or n is equals to 2, then return n as number of ways that can be possible, right? Okay, so I have find out my base case, right? By just taking small assumptions or small like sample size, I can able to find my base case. After the second thing is work. I need to define my work. So the work is at every iteration or at every recursion call, I'm making a choice. I'm making a choice, right? A person can make a choice, right? Suppose if I am in the group, I can make a choice. I can either be, I can either want to be single, or I can pair with a particular person. And pair means only two persons. Remember guys that A comma B comma C can't form a pair. Pair means only two people. And if a person pair with another person, then he can't pair with another body, because he already paired with some other person, right? Such that he can't pair with like an external person or any other person, right? I hope you understood, right? So at every recursion call, or a person or a given person can make two choices, that either he can remain single or either he can like form a pair. So if he chooses to remain single, then what happens? If he chooses to remain single, then the number of people will be n minus 1. So I need to find out for n minus 1 people how many ways that can be possible, and I can remove this thing because he wants to be remain single, right? If a person wants to be like in a pair, then the two persons the a person will form with pair another with another person, another body, and the number of people will left are n minus 2, or in other words I can write f of n minus 2. Okay, so here one more thing we need to understand here, sir, that suppose there are 10 friends in our group. There are 10 friends in our group, and I want to like make a pair with another person. So the total number of friends for me is 9, right? In a group of 10 people, let us consider that I am one of the part of them. So for me, there are 9 friends that can be possible to pair with them. There are nine friends that can be there is 9 friends and there are 9 number of possibilities that I can like pair with 9 different people. So here the number of ways can be n minus 1. So if I remove one person, he can able to make n minus friends, n number of n minus 1 number of pairs, right? It can be possible. You can imagine like suppose let us take that there are 3 friends. There are 3 friends and A wants to be pair with suppose like ABC are 3 persons. So how many pairs A can make? He can make only 2 pairs because there are 2 persons left, right? Okay, similarly here given n number of friends, if n wants to make pair, then their total number of persons left are n minus 1. So he can make pairs with n minus 1 number of friends, right? Okay, n minus 1 into f of n minus 2. So these are the number of ways. So total number of ways will be, the inner function call will be total number of ways is equals to f of n minus 1 plus n minus 1, because n minus of 1 friends can be possible for that particular single person to make pairs. Okay, after f of n minus 2. So this is the function calling, and this is my basic base case, and these are the works I am performing. So this is my first base case, after this is the work I am performing, and this is my inner function call. All these 3 things are clear. Now I can code this thing, so by coding we will understand it even more better. So here I am creating my function friends pair, creating my function public static int type function, because I am going to return the number of ways that can be possible, right? So int friends pair. In this I am passing int n. After my base case is if n is equals to 1 or n is equals to 2, then I need to return n. After that, I need to calculate for single friend. For single, single, if he wants to be single, then the number of friends will remain n minus 1. After that, this is for my single friend. This is my work, basically this is my work for my single friend. Most of my friends are single, right? Yeah. After that, for my pairing, number of pairing, for my pairing, int pair friend friend, friend is equals to friend pair n minus 1 n minus 2. After that, here number of friends that can be possible for pairing is n minus 1, right? So n minus 1 into my friend pair, that's all. After that, here I am calculating total number of ways. Total ways int total ways is equals to single plus pair friend, and finally return total ways. That's all. Now let me save this, and in the place of calling number of like friend tiles problem, I am calling my friends pair, and I am passing n. Here let me give n is equal to 3, and we already dry run that for three friends the number of ways that can be possible is 4. So if I run this code, then I should get my output as 4. Now let me save this thing and run. So you can see that we got our output as 4. So for 3 friends, the number of ways that can be possible, either he can remain single or can be paired, are 4. Suppose in the place of like 3 I am giving like 10, then let me save and run. You can see that 9496 possible ways, there are like 9496 total number of ways that can be possible for 10 friends. Suppose let us consider that if I give like 20, now let me save and run, then the total number of ways can be like yeah, it is out of the, like this thing is giving me negative value because this thing is going out of my int range, right? Here let me give like a small value like 12. Now let me save and run. So you can see that the value is like increasing exponentially. So these are the total number of ways that can be possible for given n number of friends. Now these are the like basic recursion techniques. So up to now we have completed our chapter recursion. In this chapter we have understood like what are the 3 conditions to calculate like any function thing, any function calling and all those things. Those 3 things are, first one is we need to understand what is our base case. Second thing is what is the work we are going to perform in our like a function. After the third thing is how our inner function calling will take place, how our recursion will take place. These 3 things we need to be very clear to do any question in recursion chapter, right? After understanding the concepts of recursion, what is recursion, why it is important, and what are some examples of recursions in our real world. After that we proceeded with question like we calculated factorial of n numbers, sum of n numbers, and even odd, sorted or not, and Fibonacci series, friendship problem, tiling problem, and all those kind of problem, first occurrence, last occurrence problem, and all those important questions we have covered. And I want you guys to do the assignment by yourself. If you didn't understand these questions, then go into internet and try to do the question for yourself. First of all, do it in pen and paper. By using pen and paper, you will understand. First of all, be very clear with the logic. After that, you can proceed with the code. If you are like very clear with the logic and very clear with the intuition of the code or the problem, then you can solve like the code in just minutes, in just seconds you can solve the code. You should be like very clear what is going on in my code, what are the things that I am taking. After all those logic, after you are clear with the logic and you have done your code on the paper, then you should proceed with the VS Code editor, right? Up to now we have completed all the important questions, all the important concepts of recursion. Now we are going to do a simple chapter, at the same time very interesting chapter, that is divide and conquer algorithms. So with that being said, I will see you in the next chapter.